the last, just because we are here waiting for PG17, right? And Bharat actively contributing in PG17 and then being in the top 30, right now there was top 50 contributors that we saw on the LinkedIn post by Robert Haas, but Bharat being in the top 30, we are super proud of that stuff. And kudos to Bharat. Right. Next, I'd like to invite Bharat to talk about what is super interesting in PG17 and what we should be looking forward and what we should be testing that is already in the beta. But do you have the beta available for? It's only 17 there, right? Faster than your seniors.
Yes.
No, it's one day.
Yeah.
My name is Bharat Rupireddy. I'm a PostgreSQL contributor. I would like to thank everyone for being here today. So when PostgreSQL 17 is around the corner, within 2 months the features will be going to happen. I think it's high time for us to just look into what it contains actually, what it has to offer. So that's what all of this talk is about. So we'll look at some of the improvements to the logical applications with PgHyd or application slot. Failover and backup, incremental backup, as well as some of the observability things like new system use and log messages to help debug the instances and issues. Also, we'll look at the option for logging, which helps for bulk loading. And we'll also look at one interesting thing: how do we test the transaction ID wraparound? We would have heard what is that transaction ID wraparound, but how do we test whether our instance works or not, or settings work or not? So let's also evaluate the improvements and right-hand logging related improvements. We'll just go over all of these things. Yeah. So first feature is upgrade of logical application cluster. Basically, the logical application cluster is what a set of PostgreSQL instances set up for logical application. Of course, you call them as publisher and subscribers, and publisher is where the changes are decoded and sent to the subscribers, and publisher uses the replication slots to track the changes, and the subscriber receives the changes. It also uses data structures like replication origin and tables to track the received changes and applied changes. So now let's look at what the problem is, right? So when logical application is set up on PostgreSQL instances, and if you want to upgrade, right? So the logical application will not work after you upgrade your instances. The problem is your PgHyd will not take the information that is available in the old cluster to the new cluster, like replication slots information, and all of these are necessary for the logical application publishers and subscribers to work on. Your PgHyd will not carry them from the old cluster to the new cluster. So that's the problem here. And now, what happens if that's the case? So you have to recreate the entire logical application setup after you upgrade your instance, which means you have to create the replication slots. You have to recreate your subscriber, right? When you say recreate your subscriber, you have to do that initial data sync and all of that, which is kind of time consuming, right? When you're talking about the data in terms of terabytes. So these are all like the extra work that is going to be needed for if PgHyd cannot solve this problem. But good news, we have developed a solution for that. And in first part, what we have done is we have taught the PG upgrade to get all of your replication slot information without losing any data from the old cluster to the new cluster. Right? This is from the publisher perspective, this is solved. But still you have another problem with the subscriber, right? When you are upgrading the subscriber instance. Yeah, so also we have taught the PG upgrade to get all of your data that is required from the subscriber from the old cluster to the new cluster. That is, for instance, the application origin or the catalog information that's needed. With these two features in, right? With these two commits right into the PG17, you don't have to recreate any of your publishers or subscribers. All the work that is required otherwise is gone. So your logical application will work seamlessly after you upgrade all of your instances to newer versions, starting from PostgreSQL 17. So we avoided all of that extra work and initial table sync and creation of the publishers and everything. You just need to point your publishers, subscribers to the right, the new upgraded publishers. That's all you need to do. So everything will be taken care of, would have taken care of by the PG upgrade. Any questions on this?
What happens under
Sorry?
What happens under the hood?
Under the hood. So the PG upgrade, when it is copying out the data from old cluster, it also copies the data that is required from the further logical application.
Data that is stored in the PG storage.
Correct. And not just that, it also ensures that no data is missed. While you are upgrading, you will generate more, right? So it will take care of all of that. No data, no change is missed. And it will get all of your application slots for the publisher, for the subscribers. It will get all of the state, subscriber state, like application origin. Where did my old cluster was when it was in the logical application as a subscriber? So all of that information and real state. Let's say if your old cluster is old subscriber is initializing or doing some initial table sync. So that information also gets stored into the new cluster by PG upgrade. Let's move on to another interesting feature. So we have this logical application slots, right? So just now we have talked about logical application slots we use for publications, right? For the publisher side. And the high availability model that we have not talked here is you have a primary and set of replicas connected via streaming replication. Right? We have streaming replication or physical replication and logical replication. Right? Streaming replication or physical replication is just a binary replication. So you have, let's say, one primary and two replicas. And then your failover target you would define it as the most up-to-date replica. Up-to-date as well as available replica. So when something happens, like your primary goes down, or crash happens, or the region or whatever conference goes down, so you typically define your cluster to be very equal to one of your targets, replica targets. Right? So all good, so far so good. But what if your architecture the model has this setup also, right? Say you have set of subscribers connected to the primary, right? Logical application, which they use application slots and all of that. Now if you do the failover, right? With logical subscribers in place, if you do the failover, your replication slots are not going to be available on the new primary after the failover. Because streaming replication will not get you the replication slot information onto your replicas. So the problem is you need to recreate your subscriber from the scratch, doing all of that table sync and everything. I mean, whatever you do as a new subscriber, setting up as a new subscriber, right? So that's the problem, and other open source tools have solved this problem external to the PostgreSQL, but starting PgHyd, we are having a solution for this right out of the box. That's like your replicas would periodically sync the slot information from your primary, logical replication slot information from primary, and it will get you all of the replication slots needed for your subscriber to work after the failover. So what happens is, you don't have to do anything, just you need to point your subscriber to the new primary, that's it, after the failover. So your subscriber will work seamlessly from that point onwards, following the new primary. So you are basically getting rid of the extra work here. Any questions on this?
When you change the subscriber to primary, the database will also change.
Database will also change.
Now subscriber becomes the primary.
Yeah.
So your database
Subscriber becomes the primary. Yeah.
So you have a publisher. The publisher is the master database.
Correct.
And replicas are like read only or something like that. Now one of the read replica means one of the subscriber, your primary got failed. The subscriber become primary. So in your application, will you point it to the new subscribers which now became as a primary?
Yeah. So here in this architecture, the subscriber can be on the replica or it can be on the different instance altogether. But what is the use of having your logical subscriber on a replica? Right? Because anyways you are getting all the changes on your replica. So here the hierarchy model is like your subscriber is different from your replicas. Your subscriber instance is different. After the failover, the connection string information, again which you are pointing toward the last library, you just need to change that host address to point to your failover, the new primary, the failover. That's all you do. One more interesting feature, incremental backup. Let's just look at some basics here. So the incremental backup is the one that contains only the changes or the blocks that have to be changed from your last full backup or the incremental backup, last available incremental backup. Right? For instance, an example here, you can see. So incremental backup always starts or needs a full backup to start with. So there is a full backup taken, and there are a couple of incremental backups taken, and then let's say you want to consider a full backup or you want to restore up to a certain point, let's say P here. So what you have to do is you need to have the full backup and all the incremental backups up to P. So, if you don't have any of these things, your incremental backup is not going to work, because incremental backup logs or stores only the changes from your last incremental backup or full backup. So you need to maintain all of these backups to get what is the alternative? Incremental backup. Less storage than full backup. Let's say you have to talk about terabytes of data, but within a week or so, and your backup processing is every week take a backup, but within that 1 week only the slightly small amount of data is changed. Right? Typically today you would copy or you would backup all of the terabytes of data, even though you have changed only very minimal data. Right? So the advantage is less storage. And then for the sake of comparison, let's just look at the differential backup. So the differential backup stores also starts with a full backup, but stores all of the blocks that have been changed from the last full backup. So the differential point is it stores all the blocks from the last full backup. So here let's say you've taken full backup, and these are the differential backups you've taken, and then let's say you want to construct a full database out of the available full backup and differential backups up to point P. Now what you have to do is you need to start with a full backup and just take the differential backup at that point of time P here. You don't need all of this equity because your differential backup is going to contain all of the changes from your previous full backup. Clear? So the advantage, of course, it occupies less storage than the full backup, but of course more storage than the incremental backup. So PG70 added support for incremental backup, and with the existing tool like PG based backup, you can take the incremental backup. But to construct a full database using incremental backups, new tool is introduced, PG combined backup, right? And then internally, you might ask the question like how server maintains, what server has to do for one to take incremental backup, right? So the server maintains a list of changes, like from last point onwards, from certain point onwards, what are the data blocks that have been changed. So that information is maintained by the server for enabling incremental backups.
So is it kind of a logical sequence?
Correct, exactly. The wall. You can look at the wall, right? So in the wall you will have what of the blocks that have been changed. So that's what they do.
Any catalog table has been introduced. So this both is any catalog table has been introduced for this both.
Not that I know of, but yeah, no, I think but we'll have to check. New process for doing the wall summaries, the list, preparing that list is introduced. So when do we want to use incremental backups, right? So obviously when there is a huge amount of data, your data size is in terabytes, let's say, and then only few bytes are changing, or few amount of data is changing. Obviously you can store huge on your storage costs. That's where you can use incremental backup. But if you have small databases, but even though you are modifying very less amount of out of that small database, it's good to go for full backup because of the maintainability that comes in the incremental backups. You need to maintain incremental backups, and to construct you need to use new tools and all of that. So it's good to go for full backups in that case. And if you have large database and you are modifying the data heavily, then also good to go for full data backup. Because the storage is going to be equal to that of the full backup. Any questions?
Yeah. The progress backup, PG progress backup.
Okay.
Are we updating any additional information into the progress code?
PG system.
PG stack, base backup, progress.
Oh, PG base backup.
Yes. Base backup progress. There is a catalog table which gives us when it will be completed, when these every backup table.
Not sure on that.
We'll take a look at it. And second is PG13 introduced backup underscore label 5 for the base backup. Are we like those are we capitalizing version by version on those new things? So is there any place where we can go ahead and see, hey, this is the history of changes that happened that built up to this particular feature?
Correct. So the incremental backup thing is heavily built on your existing PG-based backup mechanisms. So it uses backup manifest points and backup labels. All that has not been changed. So it is only built on top of that. So just that you need to maintain your incremental backups properly, and you need to use the extra tool, PgHyd, to construct the full database, and you need to use the PG base backups new options to taking this incremental backup, as well as on the server you need to enable the new process, that is wall summarizer, which creates that list of changes.
Sure.
Yeah.
So we have any protocol time limit for incremental backup, like for 5 minutes or frequency set, or we can.
It's up to you, it's on your choice.
So it's not default like 5
No.
minutes like transaction law.
The tool has to be run by the maintenance, like your maintenance jobs.
So my point is that if we reduce the time rate, we'll get more incremental backups. I mean, of course, the
Right,
tool will
that's
take
right.
care.
Yeah.
And the tool will take care. The number of backups would increase. Right? So we have
Correct,
any
correct.
what is called user input changes for 15 minutes or 20 minutes. Time interval so that I can capture that.
So as far as the backup to process is concerned, it will not, depend on, and it will not automatically take the backups based on the data changes or the time or whatever it is. It's the maintenance part that has to take care of that.
Right, but I just want to compare the T log, like SQL Server, so you can get till 5 minutes time you can give it. So in that case, they have any inputs timing.
Not that I know of,
So
but
if I can answer,
yeah.
I'd like to answer. So basically, the PG based backup with all these additional features, it is our responsibility as database engineers to schedule this additional backups. Right? To your point of having multiple incremental backups on a daily basis, I mean, in a day you might want to look at, hey, these are my peak times. After the peak time, say an hourly incremental backup. The onus is on the database administrator and the engineer to schedule them via cron, via any of the scheduling tools, right? So the PG_base backup is there, and then it is giving us the options. Again, the onus is on us to make sure when do we want to do, what is the scheduling we want to do, and what frequency we want to do, right? To just work with your RP and RDO numbers.
Can we sign this backup to any other server? Wherever your server is not.
Yeah, it's again the maintenance thing, right? So where do you want to store your backups? So that's all.
No.
So
Both sides can elaborate this question.
Yeah.
I have a PG base backup, one full backup, 3 or 4 incremental backups, right? I have transported the full backup, the first 2 incremental backups, right, to another server, S3 or any other recovery server that I have. Do I have to transport the last incremental backup also for me to leverage the full backup and the last? How are they talking to each other? How is that? I mean, this is more of Tarak's question also. How do we track that as a catalog?
Yeah, that's the part, right? So it is built on the backup manifest in the base backup, right? So that infrastructure has this manifest files. If you look at your backup agent, right, today below the PG17 versions, right? If you look at one of the backup, you will have the manifest files. So the manifest files will help you figure out the connectedness. See, this incremental backup is connected with previously over this incremental backup. Again, the log sequence numbers are helping out there. There is a connectivity. To keep it in example context, right? So let's say you have one of this is missing. So today your PG combined backup, which helps you construct a full backup, fails because the connectivity from this backup to this backup is missing here. So that is tracked. We'll look at one more item, that is some improvements related to right-hand logging. So today we have a wall that's written, right-hand log that is written, generated by the PostgreSQL and then written to the disk. And there are wall readers available. Let's say for replication, you need to read the wall to to send it to either your replicas or the subscribers, right? You need to decode and send all of that. So you need to read the wall. So today, wall readers, they read it from the disk after the wall is written to the system. But there is Postgres has this wall buffers in between, which it uses as cache. Right? First the wall is written to the wall buffer in the cache, and then later on it gets pushed to the disk. So one of the changes that is proposed is why not leverage wall buffers as cache? So in typical way, the cache is like first we look at the cache, and if it's available, read from there. Otherwise, go read from the disk or the file. So that change is proposed. Of course, the benefit is increase. I mean, we can increase the system I/O throughput because we are not performing discretes here. And when all direct I/O, right? Direct I/O is something like you are bypassing the OS cache. So OS also has this page cache, right? So if you are reading a file, it doesn't mean you are reading the I/O. You are reading the physical disk there. So OS maintains for every cache. So there is one feature, of course, it is in the making, not there yet for PG17. We are going to have the asynchronous I/O and direct I/O very soon. So when that is in, right? So this feature can help you leverage your wall buffers as cache. So that is one more advantage. And also it helps in implementing a couple of other features in the future. Like we can today your synchronous replication, right? Your streaming replication has this synchronous mode. You can specify synchronous standby names, and so that your commit latencies would increase, of course, right? It has to get the acknowledgement from your replicas. But when you leverage this feature, you can improve performance too. Because we are not reading the disk, our synchronous acknowledgements, we are just directly replicating from the wall buffers. So the acknowledgements are going to get faster, so that your performance will improve. And then you can today to send wall across to replicas, right? They have to be written to the disk. Then only it will be sent to the replicas. So you don't have to do that if this feature is leveraged for replicating directly from wall. And a couple of other improvements we can do with this enhanced write. And there is one more wall related optimization. So when we are writing wall to the wall buffers, we take multiple blocks to avoid the concurrent writing. So there is small optimization that went in which can improve the performance of highly concurrent write workload by 2.5x. Any questions?
The VAS generated on a slave that can be used for pointing target or
Generated on replicas.
replicas, yes.
Okay. So if the wall that is generated on replicas is basically you can't generate the wall on replicas because you just have to get from the primary. So essentially the wall is binary, right? The streaming representation is binary. So that wall is like almost not almost, everything is same as your primary key. And when you can use your primary generated wall generated on the primary for PAPR, you can use the wall that is available on the yeah, so some event trigger related improvements. Let's take a look at that as well. So basically, the event triggers are nothing but kind of triggers which are fired on some of the events, like DDL creation, DDL drop, and table rewrite, all of that. So they are the specialized triggers which get fired by PostgreSQL when one of these operations are run. So you can write them in any of your favorite language, just like in your figure. is like, let's say if your trigger function isn't behaving as you expected, or it is having some issues. So today, to debug that, you need to enter into a single user mode. And you entering into a single user mode to debug something like this on a production server, you can imagine. So, if the trigger is faulty, only. But starting PG17, we are going to have a configuration parameter which you can just disable the event triggers and look at the functionality and take that function to your test environment and the data of whatever is required. Debugging. So you don't have to enter into a single user mode. And one more interesting feature. So far the event triggers are fired only on DDL creation and drop and table rewrite and so on and so forth. Right? But starting PG17, you are going to have your event triggers fired for login events. When a user logs into your system, the defined trigger, the trigger that you define gets called. So you can define certain actions there and enforce some rules, or verify whether the connection, the user is having appropriate permissions, and all of that we can do in this new login trigger. So some of the examples, like in the trigger implementation, you can grant roles based on the time of the day. Right, during the daytime, you can see the user that's logged in is having only these many permissions. You can set all of those things in this login triggers. You can verify the connections, you can control the permissions, all of that. And one more feature is we have this reindex command, and which is a DDL command, but event triggers are not fired on when somebody is running reindex. But starting PG17, your triggers are fired when you are performing reindex command. So the benefit is you can track how many indexes are being recorded and reindex, all of that you can monitor. Any questions so far? Any questions on the event triggers? There are some of new system views and log messages which help you monitor your database server interaction. So one thing is you're going to have a new view called PgHyd checkpoint to get to know what's happening with your checkpoint, all the stats. So until now, you are seeing these stats in PgHyd. But starting from PG17, it's going to get a new view.
Behavior is still there.
It is still there. So it only shows the background writer related stats. Now the checkpoint stats are separated into the new view. And there is this new view, PgHyd events. So if you had looked at PG start activity on your production systems and looked at the wait event and wait kind and all of that, I'm sure you would have hopped between the docs and then the views, right? The PG start activity terminal. So that's not going to happen from PG17. So you can, as shown here, you can join PG start activity with PgHyd events, that's new view, to get the description of the waiting. And replication slots we'll talk about, right? So, and we don't know right now when the slot has been inactive and how many times it's been inactive. All of that information isn't available today. But starting PG17, you can look at the server logs and get to know when your slot has become inactive and understand some patterns logs can help you. Yeah, this is also one of the important things here. So what it adds is when you are trying to restore or do a PITR from a backup, right? So you would have the backup label and which gets converted to backup label or gold and all of that happens. But in server logs, and all of that happens and on file system. If you have file system access, then only you would get to know, hey, this server is recovered from a backup. But starting PG17, you are going to have log messages saying you are recovering from a backup, or you are recovering from a backup, but something happened, but you restarted, but your previous recovery was from backup. So and these log messages will help you to observe the recovery related issues and debug them and analyze without having to go onto your file system and look at backup label and all of that. Okay. So one more interesting feature. Copy from command is going to have a new option to skip the malformed data. So for your bulk load tasks, let's say you have billion rows. Just if your last row is malformed, today your copy operation, the effort is entirely gone. You have to restart, filter that data, and you have to restart the entire copy bulk loading operation, which is kind of wasting efforts. That's why you have this option. Either stop at the first error that you encounter, which is the default as you see today, or you can say that just log what the error is and then add. So you would get which line is corrupted. You can, and then your copy operation continues. And after that, you can just go look at your error log and then see, hey, these are the rows that have been, malformed or corrupted, and just fix those things. You are not wasting any of your time.
These practical changes.
That's the option. This new
When
option.
we say on error, are you expecting the user to form the data, form the errors into a
Either we have to say on error equal to stop or ignore. So the error log, the corrupted data information is written to
on error report actually goes to STD or
I think STD log.
or we can push it to a file.
If you have the server log file, I have to check on that actually. But there is a file generated.
As long as it is STD, it should be fine.
It is. You will get the result. You can fix only those columns, those rows that take them.
But still the database is ready.
Yeah, it will just skip the corrupted rows, that's it. It will not insert those rows. Instead of erroring out and erasing the entire work, it just skips the malformed rows. The last one, transaction ID random. So, some cases we have 32 bits transaction IDs, and then if the system is running for a long time or heavy transactions, then it wraps around. So the solution is to do stacking, right? But all of us have read about this and might have faced these issues in production. But if there is a way to test our instances before production, right? It will be good to test all of it will be good to verify all of our configuration, active related configuration, whether they would work on production or not. So there is a test tool available in PG17. You can play with it. But don't do it on your production system. Of course, it's a test module, so it might not be available on production systems, but but the configuration parameters that you are going to set for your production system, you can take them and test with this extension. Yeah. So this brings me to that. We have this feature phrase in April 8, 2024, which means the features after that point I am not going to get into PG17, and after the thing will be cool off period where people like you and me, everybody starts testing the features, putting the bugs, stabilizing this, and then the actual release happens in somewhere in September 2024.
Release date September 20.
Sorry?
Release date September 22.
22, is it finalized?
6-7 months.
Yeah.
So it
This
is
the date is not finalized, but it happens somewhere in September.
Do you have beta version also?
Huh?
Do you have beta version?
Yeah. Meanwhile, you will get the beta versions before.
एक बीटा, एक RC1, एक RC2.
No, I like the copy feature. The copy is very much useful.
Oh, great.
भाई हरी को पूछो पीजी बेस बैकअप का कितना यूज होगा?
There are many other.
Can we suggest one more suggestion to the Postgres community?
You can.
Now, why I am asking is the copy is much more important when you have a bulk data, and the copy is also important when you say I have a copy. I do not want to insert into the data, bulk data, but I want to insert into 10 table. And on 10 table, again, I have seen customers data. On 10 table, it will join into the main table. Out of that data, it will delete the existing data, and it will generate the updated data as an update, insert new data as an insert data. So everything what we have to do, just imagine, one of our customers has got data from 85 different sources. So 85 different sources have different kind of CSV file.
Okay.
And then they load it into the temporary table. But that is in the SQL server. So in Postgres we load it into temporary. But in the SQL server they use select query and then the CSV file as a table also. And you can directly query. So instead entire data will be loaded into temporary table and then you create a index on it and then join it with your existing data. So it will avoid so many things like
It's copying. Right?
uh,
As far as I know, that kind of thing is not there. Directly accessing CSV or JSON or whatnot, other files directly in the queries. But there are some extensions, I believe. Again, stand correction. There are certain extensions that can offer that capability where you don't have to load. You can temporarily, use the file location of that CSV file, for instance, in a select query.
but the copy why it is reporting the way it will report it is very good because one of the use cases when it fails the PG copy command will give this is the file name, this is the record, starting record, and that file is saying you cannot open it in any editor. So you have to use some kind of another editor, go back to find out the search and do it. If it will report you directly and it will continue on. Yeah. So we can, that is really very good. File. It will convert as a page.
So there are many other interesting features out there. Out of close to 900 commits, and then there is a disclaimer here. All of these features may not make it to final release. It depends on the testing, the bugs, and whatnot. However you do, you create all of these features, and if you find and break the code, huge issues, it's gonna get reverted. That's the disclaimer here. And all I want you to do is to go and start testing these features and contribute back to the community. Report any suggestions, improvements, bugs, performance, do some performance testing. All of that. And of course, don't place these things on your production system. Don't upgrade your production system to PG17 as and when that's available and then start testing from there. Do it on your standards.
Well, you have some numbers around some of the features and stuff, right? So, you have any, go back to the slides. Say, for example,
Yeah, this one.
go back.
This thing.
Yeah,
14. Yeah, the references.
Right, you have the references in there listed out? Okay.
Earlier I was having all of these comments there, but the text looks so.
Say full reference.
That's it.
Yep.
So I have. Thank you.
Awesome.